Okay, exciting things here. We're going over another paper, and this one is measuring the impact of early AI on experienced open source developer productivity. Very controversial paper. If you've been following along, basically says devs are less productive with AI. We're going to dig through this paper. We're going to get to the bottom of it. This is relatively new, so I think 25th of July, but let's take a look at the abstract here. Despite widespread adoption, the impact of AI tools on software development in the wild remains understudied. True. We conduct a randomized control trial to understand how AI tools at the February to June 2025 frontier affect the productivity of experienced open source developers. Okay, so we're using pretty recent models. Coming up to June, now we're in August. Of course, we've already had GPT-5, Claude Sonnet 4, so we're probably going to be talking Sonnet 3.5, 3.7, and you can see here we are. Off the bat, we're looking at 16 developers. Whoops, moving underlines there. 16 developers, which is a very low end, with moderate AI experience. So this is a key here. We're going to really dig into how much AI experience these folks actually have. Complete 246 tasks in mature projects. This is also important. What is a mature project? Probably a really large code base. It might be written in a language, maybe a non-standard language. Most AI tools are better at Python or TypeScript. Yeah, we don't know. We're going to have to see. Each task is randomly assigned to allow or disallow usage of early 2025 AI tools. And by early 2025 AI tools, they mean Cursor, just to clear that up. So this is kind of another kind of maybe flaw in the study, but we'll get into that. And we're using Sonnet 3.5, 3.7. The authors found that developers forecast, so they think AI is going to reduce completion time by 24%. After the study, they estimate it that it reduces completion time by 20%. They find that it increases completion time by 19%. AI makes you less productive. That's essentially what we're saying here. AI makes developers less productive, but developers think that they're becoming more productive. Surprisingly, we find that AI actually increases completion time. AI tooling slowed developers down. This slowdown also contradicts predictions from experts in economics. I mean, who really actually listens to this stuff and ML? To understand this result, they're going to collect and evaluate evidence and go through sort of size and quality standards, developer experience, blah, blah, blah. The robustness of the slowdown effect across our analyses suggests it is unlikely to primarily due to be a function of our experimental design. We'll get into that. I disagree. We're gonna tear this apart. I think it's actually hilarious that they mentioned that in the abstract. But we're gonna break this paper down. We're gonna go through it section by section. You're gonna understand exactly what the takeaway is by the end. So, introduction. AI systems can affect outcomes without productivity actually increasing. For example, code can be more verbose, but functionally equivalent, and tasks can be broken up into multiple smaller tasks without the total amount of work changing, making it challenging to interpret these results. This is a really good point. I've experienced this. You can generate code, not actually know what you're doing, get to something that works, and then it takes you longer to actually understand the thing than if you just sat down and understood it. I agree with the authors here. I think this is a good point. And so let's take a look at what they see here. These are like forecasts. We have, experts saying that AI is going to speed things up, and they're seeing that AI speeds things down. Something to note here, off the bat, this is what's known as a confidence interval. It's kind of important. And this is already, the confidence interval is somewhere between 0% and 40%. So big claim. I would already argue the big claim is in question after seeing this giant confidence interval. And you can probably tell from my tone, we're pretty skeptical of this report. I'm biased, but we're going to be very honest and go through things. So what did the authors measure? We measure the impact of AI tools on developer productivity. We conduct a randomized control trial by having 16 developers, very few, for a study that's going to then purport that this is how all developers or all open source developers even behave. Complete 246 tasks on well-known repositories, 23,000 stars on average. So these are pretty mature open source repositories, pretty popular open source repositories. And so then basically the authors find this decrease in efficiency based on the forecast and what we thought would happen. So the way that they're measuring this data is manually labeling recordings of developer computer screens while they work, which represents 29% of the total hours spent by developers. This is important. Okay, we're going to measure these recordings, but that's only 30% of the total developer time. So there's a lot of stuff that's going on here that isn't writing code, and that's going to be important. So using these various sources of data, we identify 21 properties of our setting and experimental design that we hypothesize may contribute to the slowdown effect. We group these into 4 categories: direct productivity loss, experimental artifact, factors raising human performance, and factors limiting AI performance. We find evidence that 5 factors contribute to the slowdown effect. We find mixed, unclear, no evidence for 10 factors, and we find evidence against 6 factors contributing to the slowdown effect. We're going to break these down. This is probably the most important takeaway from this paper. We're going to get to that in a second. We can't completely rule out the impact of experimental artifacts. The slowdown appears broadly robust across a wide range of experimental design decisions. I'm going to push back on this, but I'm not going to push back on it with emotion. We're going to get to the facts. Many of the factors we find evidence for contributing to slowdown are specific to the setting we study. That's important. And it's actually cool of the authors to call this out. These results do not imply that current AI systems are not useful in many realistic, economically relevant settings. At least they're being honest. Furthermore, these results do not imply that future models will not speed up developers in this exact setting. This is a salient possibility given the rapid pace of progress in AI capabilities recently. It remains possible that further improvements to current AI systems or domain-specific fine-tuning could yield positive speed up. So, I think we'll give credit where credit's due here. This is honest, and it's nuanced and true. So the authors are saying, hey, we measured these experienced open source devs in a very particular setting. This doesn't apply to everyone, and this could change. So credit to them. That being said, I think that even the claims that they are making here are a bit dubious, and I would even argue disingenuous, given what we'll dig in for this research paper. So background, speed up, but on synthetic tasks. Basically, they're saying everything that we've measured in AI so far has been on synthetic tasks, and it's not real-world applied data. Speed up, but with non-fixed outcome measures. We're looking at like lines of code written, which is not a really good measure of speed up in the wild. There are impressive benchmark results, but that doesn't really tell us anything. And there are heterogeneous effects by experience. For example, maybe beginners see more of a speed up. Maybe, there are different effect sizes based on the experience that somebody has in software development. They're kind of going to say, hey, we're going to take a look at some of this stuff. These heterogeneous effects motivate our focus on highly skilled open source developers. I thought we were talking about AI programming, and now we're focusing on, like highly skilled open source developers. That's not a heterogeneous group. That's a very specific group. To be fair, the title of this paper is, if we go all the way back up here, Measuring the Impact of Early 2025 AI on Experienced Open Source Developer Productivity. I would argue that n equals 16 is not even a really robust number for even this very narrow group. And we'll talk a bit more about why I think this group doesn't even really represent open source software developers. So that's interesting. Let's take a look at our experimental design. These are actually really great graphics, probably some of the best graphics I've ever seen in a research paper. So we have an issue. There are 2 groups. There's an AI disallowed group and an AI allowed group. We do some training. This is important. We will dig into what this training is to set up Cursor and learn how to use agent mode in Cursor. From there, we're going to calculate the time in change from AI, label some stuff. This is like the sort of scientific piece here, and then run a speed up comparison, collect some expert forecasts and interview studies. So let's see what we've got. Recruiting experienced engineers, notably with years of experience in the target repositories. So open source software engineers experienced, are they new to AI? Do they understand how to use tools effectively? This is a big question. Also, developers come from a mix of our professional networks and from outreach to active contributors to large popular GitHub repositories. So randomized, yes, but selection bias, like probably. These are like from the same developer communities, right? And so it's likely that if you're in the network of someone, maybe you use AI more than other people. Maybe you use AI less than other people. Maybe you have specific opinions about AI. And so when they say on average, we're talking about on average for 16 people, you know, and that's a very low number. And so that means that maybe an average isn't even the best estimate here. They have 5 years of experience working on their repository, representing 59% of that repository's lifetime, over which time they have made 1,500 commits to the repo. They're also paying them $150 an hour, which is a pretty nice check to participate in a study. So we have really large, mature repositories. I think it's important to study AI on these repositories because most AI projects tend to be like demos that you see out in the wild today. So it's unclear, at least to me, you know, like how that changes on these larger repositories. So yeah, we get it. They're very mature repositories here. This is in a sort of an illustration of what this might look like. Forecast without AI, forecast with AI, issue randomization, AI disallowed. After issue completion, we kind of get these characteristics. So these are real issues completed during the study. It's important to note. Experimental design. Developer provides a list of real issues. Issues are typically bug reports, feature requests, or work items. They range from brief to detailed analyses. And many issues are defined before the study period begins, but some are created during the study period. So after collecting this issue list, right, developers forecast how long each issue would take if they were to complete it both with and without AI assistance. So we talked about measuring that. If AI is allowed, this is actually really important. Developers can use any AI tools or models they choose, including not using anything. So no guarantees that in the AI is allowed group that AI is actually being used. We're going to continue here because we've discussed this largely. AI tools and training. Two popular means of using modern LLMs, AI tools, are web-based user interfaces, i.e. ChatGPT, and the integrated development environment, Cursor Pro, or like any of the other tools that you've seen come out, or Replit, or whatever, right? You know, I might be biased here. Cursor is a fork of the widely used VS Code ID with near identical features that additionally includes extra AI features. That's no comment. Like a large language model chat interface and an AI agent tool that can search and edit files. Yes, this is Cursor. We all know what Cursor is. Developers have a range of experience using AI tools. 93% have a prior experience with tools like ChatGPT, but only 44% have experience using Cursor. So note over here, I say, I found most devs still aren't using these tools effectively. Big question. Did the devs in this study actually use these tools effectively? And what they're saying here is less than half have ever used Cursor before. So you're bringing in 16 developers. 44% is probably 7 out of the 16 that have used Cursor before. We're going to provide developers with Cursor Pro subscriptions and conduct a live basic training, validating that developers are able to prompt Cursor effectively. What does that mean? We're going to get to exactly what it means, and we're going to dig into why this is already starting to be suspect, because what we've got is 7 out of 16 devs have used Cursor before. We're going to break this down even more as we go through this study. Contributors completed issues largely as they would outside of our experiment, with a few exceptions. They typically record their screen. When using AI, they often use the Cursor. They often use the Cursor IDE, which sometimes differs from their normal development environment, i.e., e.g., NeoVim and PyCharm. So, experimental group sometimes uses Cursor, often different from their normal editor. Interesting. The devs weren't using VS Code before. You can see I was very puzzled here. The developer experience is changed. Basically, what I'm saying is, hey, you know, imagine every shortcut in your editor changed when you switched over to this new editor, and you had to change your entire development workflow, basically. Do you think experienced devs with maybe like an hour or two of training on this thing and new tools would be able to understand how that works? We're going to find out. And we're also going to dig into exactly what that training looks like, because that is important. So most of this stuff is about supplementary data collection. I didn't find it to be terribly relevant, or I mean, it's important, but not for this video. We're going to look at the qualitative results in section 3.3 here after we check out the results of the study. Let's check out the results of the study. This is exactly what we thought we'd expect. Forecast AI disallowed, forecast AI allowed, observed AI disallowed, observed AI allowed. So we forecast that AI is going to like decrease time. It actually increases time. It's kind of what we talked about. here's your results that we already covered based on those forecasts. This kind of also shows the same thing, distributions of observed implementation times. AI allowed implementation times actually were more accurate than AI disallowed based on what the developer estimated, which is maybe interesting. Their expectations regarding the usefulness of AI assistants are reversed. So that's kind of what we've been talking about this entire study. So let's dig into like some of the more detailed cuts of what we found, or what METR found in this study. So what you're going to notice is that when AI is actually allowed, active coding time decreases, research and searching time decreases, testing and debugging time decreases. And yet the outcome of this study is that AI is bad for productivity on open source developers. Interesting. So when did AI add overhead? Reviewing AI output, that's expected. Big increase in time, 0. Prompting AI, yeah, that doesn't exist if you're not using AI. Waiting on AI. This is training, right? An effective use of AI does not involve waiting on AI. An effective use on AI is going to lower your time prompting AI. And an effective use of AI is going to lower your time reviewing output. Some other things, again, good to call out confidence intervals here. These may be overlapped, so testing and debugging might be equal. Idle overhead, I don't really know what that is, but these also are, for all intents and purposes, equal. But it looks like there's some preliminary evidence to suggest that AI is actually going to improve these things. And the result I'm taking away from this paper is that there's not enough training around how to do these things efficiently. Because if we brought these down, if you're spending 10% of your time prompting AI, that feels like a lot of time. We're going to figure out what's going on here. So I think that this is one of the most important parts of the study, the factor analysis. So we're going to look at what the authors call direct productivity loss, experimental artifacts, raises in developer performance, and limits in AI performance. And we got a big old table here that's going to go over this. So factors likely to contribute to slowdown, over-optimism about AI usefulness. It's actually a good call out. Sometimes I assume AI can do more than it actually can, and that gets me into a position where I make mistakes that actually set me back. High developer familiarity with repositories. This is self-reported by the developer. Developers slowed down more on issues they're familiar with. So developers told the authors of the study, hey, I slowed down more on this thing because I know what's going on in this repo. Developers report their experience makes it difficult for AI to help them. That's another training issue. Now, it's important to note, right, like based on the legend we got here, they're saying this is things that raise developer performance. This seems like it would actually just hinder developers from using AI effectively. So this is a bit of a question mark. That was an ugly question mark. Large and complex repositories. This is important and I think needs to be studied further. Low AI reliability also probably needs to be studied further. Developers are accepting less than 44% of AI generations. So I love developer education and I love education on AI tooling. So this could be a very biased take, but if you're prompting AI and you're accepting less than half of what AI is giving you, you're not prompting AI effectively. I believe that's true of models today and also models 3 months ago, Sonnet 3.7 and Sonnet 3.5. You should have a much larger acceptance rate than less than 44%. Majority report making major changes to clean up AI code. That's pretty normal, but also suggests maybe some prompting improvements. And, I think this is like largely, right, like context engineering. If you're having to clean up AI code and the AI code isn't conforming to your standards, right? What does this tell us? Clean up code. That means that code doesn't conform. That means that you're not giving proper context. To get outputs that conform to your standards, you have to prompt effectively. You have to create rules. You have to create examples and documentation. My guess is that these developers don't know how to use Cursor or AI tools effectively. Implicit repository context. Maybe I should have talked about this one first. Developers report AI doesn't utilize important tacit knowledge or context. Yep, this is these developers don't know context engineering. That is directly, the AI isn't utilizing important knowledge or context. That's because you have to help the AI do that thing, right? Okay. Factors with unclear effect on slowdown. Now, the author is going to say this has an unclear effect on the slowdown, and then they're going to say all of our experimental design snafus actually don't have an effect on the slowdown. You can be the judge of that. Developers sometimes report overuse due to experiment. Developers report issues are standard, but on the shorter side. Developers decide order post-randomization. Developers who rely heavily on AI may be less likely to participate. That seems relatively important. What else here? Similar slowdown for developers with prior cursor experience. I'm not quite sure about that. We'll talk about why. No clear learning effect across first 30 to 50 hours of cursor usage. It's probably because they're being paid, and also it's not their primary IDE. So imagine you're paying me to do something and giving me a tool I've never used before. What's the likelihood that I'm going to adopt that tool? And then also just like if I'm using NeoVim or if I'm using PyCharm, learn cursor on the side for fun as a part of the study, but not getting paid for it. Doesn't seem really to net out. Developer use cursor agents chat in majority of AI allowed issues. Developers may sample few tokens from models. That's a huge red flag. Unused elicitation strategies could improve AI reliability. Now the author is basically acknowledging here there was non-optimal use of the tools in this study. Non-optimal use. Sorry if I'm fired up. This seems like a very flawed study that didn't really take into account proper developer education around AI tooling. And so, unlikely to contribute to slowdown. I am very puzzled as to why developers use comparable IDEs between treatment conditions and no clear learning effects across 30 to 50 hours of cursor usage. I just think that I'm not entirely sure the empathy that the authors of the study had for developers, or if they understand what it means to switch an IDE or to teach somebody how to use a tool. Because I think unfamiliar development environments contributed hugely to the outcome of this study. And we're going to look at some of the charts here to figure out what's going on here. Cheating or underuse of AI. AI used in all but 16.4% of allowed cases with labeled screen recordings, only 3 cheating instances in 56 screen recordings. So now we're saying, oh, hey, actually 84% of AI responses actually used AI. So 84% used AI, 6% included cheating. And then we're talking about right beforehand, 7 out of 16 devs had used cursor. I'm struggling to see how this isn't just like poor experimental design, or why we're even interpreting these results as meaningful here. This is the percentage of these responses that were actually valid are shockingly low, and the authors are saying they're unlikely to contribute to a slowdown. So I don't really understand how that's possible. Now let's look at some key caveats. High developer familiarity with repositories and the size and maturity of the repositories both contribute to the slowdown. So we're going to go over kind of what we just talked about. Most of the AI-specific factors here, AI systems that have a higher fundamental reliability, lower latency, or are better elicited via more inference or compute tokens, more skilled prompting, scaffolding, or explicit fine-tuning on repos could speed up developers in our setting. The developers here are not properly eliciting AI responses, and that's the big takeaway. Agents can make meaningful progress on issues. We have preliminary evidence that fully autonomous AI agents using Claude Sonnet 3.7 can often correctly implement the core functionality. So we're going to publish this study that says that developers are less productive with AI, but we're actually running a parallel study that's going to say the opposite, and we're going to release both of them and let you decide. Interesting. Okay, then we got acknowledgements. Okay, extended discussion. This is really good. This is a really good extended discussion, and I think it's really valid. My question is why wasn't all of this discussed at the beginning of the research paper? AI systems in the near future will not speed up developers in our exact setting. Actually, that's not true, right? AI systems do not speed up individuals or groups in domains other than software engineering. We're only studying software development. We do not claim that our developers or repositories represent a majority of plurality of software development work. While our developers appear to use AI tools competently, it's plausible that much more experience could yield speed up. Again, I think all of this should be prefaced at the beginning of this study, and basically you should just put a huge asterisk or just redo the study entirely. And that's going to take us into, basically, we're going to look at section C28, which is our breakdown, the baseline, and the percent change that the authors are finding. Baseline n equals 246. This confidence interval actually overlaps with 0. So there's some chance that the 20% thing, right, like isn't actually accurate. Now let's break down these groups here. Has Copilot experience? So half devs, we're just gonna like list out the facts. Half devs have used Copilot. Has no Copilot experience. Half devs have not. That's great. Has prior cursor experience. Less than half, 6 devs. What is that? What are we saying here, right? Saying 6 devs have used cursor. We're saying 10 devs have not. We're saying actually that only 3 devs used cursor regularly before experiment. The other 13 did not. And 1 dev has never used LLMs. Let's dig into some of this stuff here because, I think this is important. So this guy who has no web dev, no LLM experience at all, we have this giant crazy confidence interval. Kind of curious why this is even in the study, right? Cursor was a primary IDE before the experiment. The confidence interval overlaps with a 20 to 25% speed up. So they're saying, oh, this could be 25%, it could be minus 60%, but actually because this group is so small, like, we're saying it's somewhere in here, like minus 15%, but we really don't know. And then these are the people that actually know how to use cursor. Everybody else effectively doesn't really know how to use cursor. So what this is showing me is that actually with proper training and like maybe some practical experience using the tool, there's much more likely a speed up. And that's because of a flaw in the study where they're looking at people for whom cursor is not their primary IDE. Now, how you control for this, right? They just said cursor is a fork of VS Code. Why wouldn't you measure devs who use VS Code as their primary E against devs using cursor? And then you'd have to provide like some several hour, maybe 2 to 3 hour training on how to use all the effective features of the specific AI tool. So that's important. Let's look at what the actual training was for this tool. Okay, so we have our onboarding call and cursor training. All participant developers started the study with a 30-minute introduction and onboarding call. Before the call, they were asked to set up an account and install and set up cursor. And so in this 30 minutes, they were shown how to create a new agent mode instance, add a relevant file to the context window, prompt the agent to do and make change to the files, accept changes or revert changes. They didn't talk about indexing. They didn't talk about documentation. They didn't talk about rules. They didn't talk about they did talk about mentioning files, scratch that. They didn't talk about when to use AI or how to use cursor. And so initial take, right, this is 30 minutes long. If you're a developer and you're watching this, have you ever got a new tool and had someone explain it to you for less than 30 minutes and thought you were able to use it to its fullest potential? Now, the argument that the authors make in this paper is that, okay, well, the devs used cursor for 30 to 50 hours, and we didn't see any change there, so they didn't really learn anything. But if you're paying me to use a tool, I'm probably less likely to use that tool, especially if I'm an experienced software developer in an open source repo that I've been working in mine like for 5 years, and I have a bias towards AI tools, which given the selection bias that we're introducing into the study by picking friends of the authors, my guess would be that yes, they do have a bias towards AI tools. So fundamentally, I think this section G3 combined with the other section we just talked about rule out this study as really relevant. And so that's kind of all I have to say about this one. The findings are, hey, we thought devs would see a speed up. The devs self-reported that they saw a speed up, and they didn't. They saw a slowdown. But then we dig into it, and it turns out, actually, they did see a speed up on code editing, on code replacements, on all these things, right? We saw a speed up on active coding, on reading and searching, on testing and debugging, potentially. The slowdowns were on reviewing AI output, prompting AI output, and waiting on AI. And those are things that are all solved with developer education. Moreover, we only recruited developers that we knew from open source repositories who primarily had never used cursor before. And so if we're breaking down this study, 16 devs, open source repositories, most of them had just not used AI properly or might not know how to use AI. I don't really know who these people are, but we shouldn't be reporting on studies where we have to get down to individual developers and individual participants. That's the whole point of getting a high end for a study. I think that this is largely throwaway. Like, you should just disregard this. I really appreciate the effort that the authors put in to highlighting the caveats and trying to be upfront. But if you're going to go out in the abstract and say, hey, this decreases open source software developer productivity without effectively training your developers, without really accounting for any sort of selection bias, without getting a higher N, and without providing proper education on the tools that you're going to be using, I don't know that you should be reporting on the study in the first place. That's my opinion on this study. It was an interesting read. It was interesting to dig into, especially after I saw the headlines on Twitter. Let me know if you agree or disagree. Obviously a hot take, but that's what I'm here for. Until next time, peace.